Hey guys, welcome to the biggest video on this series. This is an electric Ducati that Lord Kurt and I just finished building, and we're giving it away. So May 31st, 2022 is the deadline for the giveaway. If you guys want to get entered to win this bike yourself, head over to injagiveaways.com right now. Get yourself entered. But this video is not about the giveaway. This is showing you guys, every enthusiast out there, we're going to show you guys exactly how we did it. This thing does over 100 miles per hour, and we're hoping it gets about 200 miles of range or so, which is some groundbreaking stuff for you know, DIY motorcycles. So let's take you guys back in time really quick, show you guys how we built this thing, then we'll talk about it more. All right, so here she is. This is a 2002 Ducati Monster 750, and this thing has been in this barn for, I don't know, 5 years or something. And if you guys don't know, this is our next conversion project, and there's actually brand new electric technology on the market that we're gonna be using for this build. So this is pretty much it. Let's get it loaded up, let's take it home, and we'll start tearing into it. So we brought the Ducati into the garage for the very last time in its life being a gas-powered motorcycle. Disassembly went relatively smoothly, but of course at this point we had never worked on this bike before, so there was a lot of looking around, seeing what needs to come off next, labeling bolts and random bits in Ziploc bags, etc. But it only took us a couple hours getting it all the way stripped down to only the components we would need to keep for the electric conversion. It was at this point we realized that the 2002 Ducati 750 we were using posed a couple of challenges that we would need to overcome that we originally didn't know about. The biggest being the original gas engine was a structural component for the frame and swing arm to attach to. I, for one, had never seen this in a motorcycle design, and I've worked on a lot of Honda, Yamaha, and Suzuki sport bikes. But once we started looking at it and talking it through, we developed a plan and the task became a little less daunting. Overall, though, the bike was a great fit for the electric swap and just the right amount of space for an incredibly large battery pack and an almost directly swappable rear wheel for the hub motor we would soon add. Then the fun began for Lord Kurt. He began assembling the huge battery pack for this bike. One of the worst parts about building a custom battery pack is the weighting and testing of all the individual cells. Not to downplay at all the actual planning and physical work Lord Kurt did, but just the sheer amount of weeks waiting after spending a couple $1,000s on components, then hoping they all arrive in good condition and without quality control issues, starts to feel like an eternity. And if the package does come with issues, it's another eternity waiting for a new shipment to arrive and hoping you can get a refund for the original damaged parts. But because of this, we ordered a few more sets of cells than we would need in anticipation of cells being either damaged during shipping or coming with quality control issues like premature discharge. We actually did have a decent amount of cells we couldn't use or didn't want to use, so it was really good that we ordered more. With all the testing done, Lord Kurt got straight to work assembling the battery pack. Building a completely custom-sized lithium iron phosphate battery pack is obviously a huge undertaking and would be a lot easier if you could just buy a pre-assembled pack, obviously. But the price of pre-assembled packs of this size and custom dimensions and all that, first of all, no one would probably actually make one for you. But second of all, it would be so much more costly than building it yourself. Plus, building it yourself, you can verify each cell is in perfect working condition. So huge thanks to Lord Kurt for doing yet another battery build. There are in-depth videos about the process on his channel if you want to check it out more. So with the bike torn down and the battery assembled, a lot of the sub-projects start. Kurt began to assemble the battery case. Now, most of the Ducati is actually made from aluminum, so Kurt actually had to learn TIG welding for this project. It's a great skill to have in our line of work anyway, and he picked it up very quickly and made the battery case. As for me, I knew I wouldn't be a whole lot of help on the fabrication section of this build, so what I did in the meantime was just try to make the garage the most pleasant work environment that I could. So when Kurt inevitably stayed late nights working, it would be enjoyable and well lit. You can see here I installed 2 honeycomb detailing light fixtures for $750 each, and it drastically changed the feel of the garage. Worth every penny, definitely. With that done, Kurt began knocking out the first of the 3 big tasks of mounting up an electric powertrain to a stock gas bike, the battery and the battery case. His job is basically to fit the absolute biggest amount of battery in the space of the original gas engine. The original engine in this bike was a V-twin configuration, so it was narrower than most 4-cylinder sport bikes you might see on the roads. Knowing this, Lord Kurt designed the battery pack to be long and tall, but narrow enough to fit in between the frame rails with minimal modification and the best fit. Next, he moved on to the second of the 3 large tasks, mounting the swing arm. Now, you may remember from last video, or if you know Ducati motorcycles, the swing arm bolt / engine mount actually went through the engine, using the engine as a structural mounting point. Obviously, we took out the engine, so we needed to figure out how to make the swing arm mount and ride like it did before. Lord Kurt figured it out and fabricated a swing arm mount that you can see here, which he needed to bore out to 26 millimeters but couldn't with a large drill bit. We had to take it to our friend's machine shop to get it bored out to the correct size on his lathe. With the fabrication of those parts done, Captain Kirk went ahead and test fitted it all up, making sure all the electronics and hardware would fit and also be concealed underneath the tank for a very sleek look with no wires showing. He also used this time before actually putting the 160-pound battery inside the case to mount it and weld the contact points up into their permanent positions. He then moved on to figuring out the third of the three major tasks, mounting up the rear hub motor wheel. The 12 kilowatt wheel is wide and heavy, but the width of the wheel and the length of the axle was a great fit for the stock Ducati swing arm. Mounting a hub motor is a bit different from mounting a normal wheel because the axle isn't removable, so it has to slide into the swing arm in one piece, unlike a normal wheel that you put into position between the swing arm first and then slide the axle through it. So to modify the swing arm to accommodate a hub motor wheel, you have to notch out the rear of both sides of the swing arm. Kurt also reinforced the now hollow swing arm with fabricated reinforcement pieces to allow the axle to tighten onto it to accept all the torque the motor can put out with no issues, and to prevent potentially warping the swing arm. He also made an axle lock and adjustment plate based on the hub motor setup of the electric sport bike, which came stock with a rear hub wheel, so it was a good template for us to pull from for the Ducati hub motor conversion. And of course, we couldn't help but put the tire hugger on just to see how incredibly cool it was about to look. After that, I mounted the new handlebars since the original ones were dented and also just looked old. Kurt went on to completing the electronics installation and finalizing the drivetrain wiring, which was the final step before installing all the components into the bike for the very first time.
Everything's wired in, we're just gonna give it a plug and see what happens. It's always nerve-wracking.
With all the electronics functioning properly, we both installed the battery pack into the frame of the bike, which was actually surprisingly easy considering how heavy it is and how we had to tilt it to slide it into position. Now, as you're seeing this footage, you might think the whole thing looks a little crazy or janky, but remember, at this stage of any huge project, we need to see it actually run first before finishing it all up. This was to prove the concept of the electric conversion and physically see all the systems working and operating as they should. We wouldn't want to go any further if it didn't work. Everything will get buttoned up later. With the systems all working as they should, Kurt moved on to programming the controller for the optimal settings for the bike's current setup. All right, go ahead and crank it. So we had left the bike's stock wiring harness intact on the bike because we thought we were going to reuse at least some of the wiring. The stock wiring harness, of course, had a lot of unnecessary wires that we didn't need. Things like the oil pressure sensor, regulator wiring, ECU wiring, and just a lot of other things for the original gas engine. Originally, I thought I could simply strip the old wiring down to use what we need, but the stock wiring harness had a lot of dead ends that would only work if all the original computers and modules for the gas engine were plugged in. So what I hoped I'd be able to do myself and decently quickly turned into a larger project that needed Kurt's help, since he designed a whole new electrical system for the bike that I wasn't familiar with. I didn't want to plug into power or grounds that were the wrong voltage or led somewhere it wasn't supposed to and compromise all his hard work. So I at least started running wires and figuring out the wire colors for the various components and cleaning it all up. As I was doing that, Lord Kurt went on to cut and weld in the last structural bar for the original frame. You can see there's a section of the frame that all ties into one X section right in the middle of the bike, which is the most flexible spot and calling for some extra reinforcement. It was probably plenty strong, but it was a just in case type of thing. Plus, it added a bit more of cool factor to the bike. Off camera as well, we installed the display, shortened and tightened the handlebars, and just generally did a lot of small stuff that wasn't really worth mentioning. At this point in the build, most of the items left to do are nitpicky and a lot less of a priority. Of course, there were a few things to figure out that took some time and things that didn't go quite as smoothly as expected, but in the end, it all came out exactly as we wanted and fully functional.
Dude, he's cooking.
Holy freak!
Wow, sounds so cool. Dang, dude.
So finally, the very last time we had to disassemble the bike. This time was for all the finishing touches, wire management, paint, torquing everything down permanently, greasing all the necessary components, thread locker on things that shouldn't move, everything you'd expect from a professional shop doing this. I went ahead and got straight to work prepping every single individual part for paint, which, even though it may not necessarily seem like it, since I did a lot of the work off camera, was a ton of work and took a lot of time. Painting motorcycles is a much different experience than painting car components, in the sense that components on motorcycles are much smaller and intricate than components on cars that have a lot more flat surface area. For painting large surface areas, you definitely want a paint gun that can spray large patterns smoothly. I was this close to whipping out a paint gun, setting it up with the air compressor, mixing the paint, all that goes into large paint jobs, but ended up just using automotive primer and paints from spray cans, since I've had great results doing that in the past. And since all the parts, though there were a lot of them, are small and don't really require a large spray pattern. Inevitably, the battery case got a few nice scratches after we inserted it into the frame, so I had to respray those areas after the bike was put back together. Luckily, the battery will never have to be taken out again unless the new owner wants to ride it 200,000 miles and have to swap the battery out after like 30 years. Then finally came the last push to get this bike finished up. Kurt cut and organized all the wires into the correct lengths and routes, and I went ahead and polished the carbon fiber bits, added some fresh graphics to shape the bike visually and add some detail, and restored the tire hugger to make it look like it just rolled off the showroom floor. And finally, after 4 long months, the bike was done.
Alright, man, riding this thing for the very first time in its finished form.
That is so cool. So here it is. This is the Electric Ducati. We just finished this like 2 days ago. We've been just kind of enjoying it for a day or so. Such a cool bike. Lord Kurt and I could not be more happy. Could you be more happy with how this thing turned out?
Literally, I couldn't.
Dude, it's such a cool machine. And man, seeing just everything on it for the first time, every time we walk out to the garage, it just looks like a new bike.
For those of you guys who weren't impressed at the end of last video and now you are impressed, that's all thanks to the Inja putting in his little beautification work.
That's right, yeah. Like if you took it over to a family party or something, they would never know that this didn't roll off the showroom floor like this. It looks like it should be a stock bike. So anyway, that's pretty much it as far as the overview of this thing. Lord Kurt, you want to go in a little bit more detail for him?
Let's do it, yeah.
Yeah, just let's go over everything.
I'll give you the big three first off. Battery, motor, controller. Battery is some 33-140 cells from AliExpress, Lido Kala, that are running through a BMS for charge. And they're running with 128 amp hours, so 8 cells in parallel, 32 in series, so it's 102 volt nominal pack. Fully charged, it's up to about 108 because it's got a quick discharge, and then it cuts off around like 85-ish, 80, somewhere in there. We cut it a little bit higher than that for extra, extra lifetime. That all runs into the controller, which is an APT. It's under this little tank here. It's an APT 96 800. which is 800 phase amps, but it's actually also the same model that their 1000 phase amp is. So we've got it running at 1000 phase amps. Battery current, we've got up to about 475 off the battery. I ran a little clamp meter on there. We've got a shunt in here that shows what that is. So it pulls a lot of power. It's up to like close to 50 kilowatts at its highest, 45 to 50 kilowatts. So it's pulling 60 to 70 horsepower from the battery. A little bit of losses, but it's a pretty powerful setup. And then that all runs down to our QS 12,000 watt motor, which is wound so that it's got a good top speed. Acceleration is still, I would say, halfway decent. We got like a 5 second, a little over 5 seconds, 0 to 60.
It feels real quick.
And that's with a, fairly large size rider. 130 pound guy could probably get it higher. So if they tested it on the, manufacturing line and gave it 0 to 60, it could be like 4.9 they might put out,
Yeah,
to be a little faster with one of their, smaller test riders on it. And so we've got it up to high speed, 98 or so. We're going to take it up to high speed, like top speed soon if we can. Hopefully see where that could reach. I did some field weakening on it, so it might get a little over 100, maybe like 110 wouldn't be unreasonable. So we'll see what it ends up getting up to. That runs into, obviously, the whole 12 volt system. We programmed a display on here, which is the first time we've used a custom display that runs off of the Hall sensors for velocity. It's all programmed to spec. It has odometer readings on there, trip odometer, and overall mileage reading. And then we got a custom, like all this lights, signals, everything's all custom, run through a little custom harness we put together. But otherwise, it's, kind of running the standard Ducati brakes. We have braking in the back through electric braking. And
yeah, and you just wired that in basically.
Sure
I don't even know if I don't think we even
haven't
really
tested
covered
it.
that.
Yeah, so I've got it wired in to the P button here. So you'll end up, if you hit that, it'll be like about the equivalent of 2 gears down engine braking. Yeah. So it's as if you pulled the lever. It feels really nice. It feels natural. And then everything else is running the way that it needs to. It has reverse function. Yep. It's some of the perks of electric bikes, they're all coming out here in this. Yep. But realistically, the big thing that's unique about this is the drive line and the way that it's all paired together. Great outcome in that sense. And then we tried to make sure that there was no wiring visible anywhere, except for obviously what has to come in from the front, and then the line that comes out the back. But everything, if you took this tank off, you would see just a mess of stuff. Yeah. Like, it's organized best as it can be, but there's a lot of electronics here. A lot of electronics.
Absolutely.
It all runs up and runs around. The 12 volt all runs through there. We got our battery temperature displays and voltage, amp meters, that kind of thing. I don't know if it's worth mentioning, but the battery display is not calibrated perfectly, so it looks a little bit less full than it actually is. Also do some frame modification, which was a fairly large part of the project, a little extra strengthening, and an attachment point for the swing arm, which used to be in the back of the crankcase.
Yes.
So this is something that people have asked about multiple times on forums and whatnot. So you can see kind of the way that that's all welded in. It's got angled supports coming up to the back to keep that so that it can't push forward or pull back as you accelerate or brake. But that was really just careful measurements and then a simple process.
I'm looking at this bike and it just looks so perfect, and there's so many little details that add to that, like the no wires showing. Besides, obviously, if you get close up, there's the phase wires, but that's the only wires that are showing on this bike. Everything else is hidden.
Without fairings, that's impressive, because most of the time you'll hide it with plastics. There's no plastics on here. I mean, these are here because they're carbon fiber, like legit carbon fiber, and they look cool, but they're not covering anything.
They're not covering anything.
There's nothing that's hidden by anything. This is the workings of the bike exposed for the world to see.
Yeah. And if we didn't mention it already, there's a parts listed in the description for everything that we used on this build. All right, so that's gonna wrap it up for this video. What an incredible journey. We were both just on for a couple months building this motorcycle. We could not be more happy with how it turned out. It looks like a showroom bike, like it rolled off a production line, a multi-million-dollar production line, but it's just us building it in our garage, and it turned out incredibly well. But yeah, that's gonna wrap it up for this video. We obviously have an official top speed video coming soon. We have an official range test, actually showing you guys the specs we get on this, because there's a lot of videos out there of people building electric motorcycles, but they never actually test it. They're claiming big numbers, but they never actually test it, because it's not going to get that. But yeah, we'll show you guys everything that this bike gets as far as specs wise, how it rides, the full range, full top speed, and lots of other things coming soon, and the full cost. And I'll say it again, this is a giveaway that ends on May 31st of this month, 2022. So get in before May 31st, and you guys are entered to win this thing. Thank you guys so much for watching. I hope you enjoyed the video, and I hope you guys absolutely love this build as much as we do. So we'll catch you guys in the next video. Thanks for watching. Cool. That's not quite the right song, but We'll put the coffin dance meme at the end. When you get footage of me wrecking at 100 miles per hour today.